Hello students, welcome back. Let's go to number 3, probability. Here's the problem. A group of 30 college students got together. The group consisted liberal arts, business, and technology majors, as you can see in these columns. 18 of them were men and 12 were women, as you can see in these rows. The following table summarizes the distribution. Okay, all right. And this table is called cross-tabulation or contingency table. All right. First problem. If you select a student at random, what is the probability that the selected student is a female business major? So how many female business majors are there here out of total? Hey, what's the total here? How many students are there? Total is 30. Because I'm selecting one student out of this total pool. No restriction here. So the denominator is 30. And all right, I'll stop here and you can find out the probability. Good luck. Female business major out of 30. Now, here is a conditional probability. If a selected student is a woman. So unlike the previous problem, this time we have a restriction. We are not considering men, women only this time. So what's the total here? Total is not 30, women only this time. So the total is 12. So that's the total. We are completely disregarding all men here. Ladies only here. And the probability, well, you have to find out the numerator, of course, and good luck. It's not too bad. Once you see the condition, it's easy. Now, if a selected student is a business major, similar, and in this case, no hint, you're on your own. For part B, I gave you a little bit of hint. Under this condition, ladies only, women only, the total is 12. Previously, the total was 30 because this time there's no restriction. And for part C, the third problem, restriction is the major. Okay, there goes one problem. And let's go to a little bit harder problems. Probability distributions. We have a cumulative distribution function like this. So all these probabilities down here, those are cumulative probability. Probability of negative 1.5, less than negative 1.5. Probability of greater than or equal to negative 1.5, but less than 0.5. Actually, no. I said it wrong, excuse me. This is a class interval. Sorry about that. The probability is this random variable taking the value less than x. And that x is less than 0.5. So basically, this probability here is probability of x less than 0.5 as a matter of fact. And then this is cumulative probability, cumulative. So please note that all those cumulative properties are increasing all the way to 1, because we will just keep adding new. Now from here, find the probability mass function. This time, probability when x is equal to something, and should be equal to all these numbers here. Other numbers do not contribute because there's nothing there. There are only, how many numbers are there? Count. Well, obviously there are 4, negative 1.5, 0.5, 2.0, and 2.75. There are 4 numbers here. And for all those 4 numbers, each of those 4 numbers, we are going to get appropriate probability here. And all these numbers are cumulative probability. For example, and this number here, last number here, this number is sum of these 3. Add all these, then you're going to get 0.6. I'm giving away a bit too much. Okay, I'll stop here, and I'll ask you to figure out these question marks. So these are cumulatives, and these are the probability masses. Good luck. Get these, and that's the mass function. Now, once you have those mass function, probability of first event, P1, P2, P3, and P4. Yeah, okay, let me just... and then P4. Once you get all these, you can now answer this question here. Find the expected value, probability variance, and the probability standard deviation. Expected value, just multiply the probability and the payoff. Probability and payoff, probability and payoff, multiply, 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 and add them all up. Well, here only 4 multiplications and adding, so I could have simply wrote one more. Like then I don't need ... because there are only 4 of them. But this was actually the general formula. What if you had 16 of those, not just 4? What if you had 17 of those? What if you have 25 of those? Just add them all up. Similarly for the variance. Probability P1 times the deviation square. X1 value minus mu, expected value, and then square it. So X1 is this value, and minus the mu you just calculated, and then you have to square it. If you don't square, and if you just calculate all these without all these squares, then you're going to get just 0, because you're going to get pluses and minuses. So those deviations will just cancel each other, and you're going to get 0. You have nothing. By making all these squares, you're making everything positive. So probability is always between 0 and 1. That's positive. And square, that too is positive. So you're adding up a bunch of positive numbers. So that's always positive. And consequently, you can take the square root. Inside of the square root has to be always positive. And square root value is always positive. What does the standard deviation measure? That means the dispersion. How spread out those data are. So S is, this is Greek letter sigma. Greek letter sigma is really, really small. That means we have some concentration in the middle. And if this is big, that means we have some bigger spread. By the way, all these are from probabilities. So they're related to the big samples. So they are Greek letters. Okay, as for the computation, good luck. If you have this probability mass function figured out, then that's easy. Okay, so much for probability problems, and looks like I'll have to discuss problem number 5 in a separate video. Let's stop here.